And the mirror equation is fairly simple, and we'll see an equation that's very similar for lenses, that's basically identical to lenses. And it just tells us where the image is for a spherical mirror based on the image, the object distance, p. Looks like this: 1 over p plus 1 over q is equal to 1 over f. Don't forget our various notations for the signs of these. So, for example, just for now, actually, that our q is negative for virtual images, and it's positive for real images. All right, I'll have a table to summarize all these various notations in just a bit. Now let's also think about the focal length for this, because the focal length will be different for different mirrors. First of all, what is the focal length for a flat mirror? Now let's imagine that I have a concave mirror. Here, I'll draw a couple of concave mirrors. All right, here's a concave mirror, and the focal length is really small. But as that concave mirror gets more flattened out, the focal length is going to get bigger and bigger. So you can imagine then that if you have a flat mirror, that the focal length is going to be infinite. All right, so does this mirror equation apply then for flat mirrors as well? Well, let's see. Let's just put in our focal length. 1 over p plus 1 over q is equal to 1 over infinity, which is equal to 1 over infinity, pardon me, is equal to 0. So also don't forget that q is equal to negative p. So I can say then that 1 over p plus 1 over negative p is equal to 1 over infinity, which is 0. So the mirror equation does apply for flat mirrors as well. Well, let's look at this little table, and I'll explain what this means. We have a couple of different things that I've already said, and then one new thing. All right, the things that I've said already, that your object distance is positive if the object is standing in front of the mirror. This is a normal thing, right? If I'm standing in front of a flat mirror, my object distance is positive. I also said that if my image is, if it's a virtual image, then my image distance is negative. So my image in this flat mirror is going to be q, and q is less than 0 because it's a virtual image. Now, a couple of things that are different. Oh, and then also the focal length. No, we'll come back to that actually. Now, if the image is in front of the mirror, then it has a positive image distance. If the image is in front of the mirror, it has a positive image distance. Remember, a positive q means that it's a real image. And a real image is defined because it has to be able to be projected onto a screen. Right? So in order to be projected onto a screen, it has to be in front of the mirror. Now, this is the tricky thing, and we'll see this a little bit later. If the object is behind the mirror, something we would call a virtual object, because you know you can't really stand behind a mirror. That doesn't really make any sense. It'd be like in that movie, if y'all seen that movie Poltergeist from like the 80s. You know, walk into the light, walk into the light. You can look it up on YouTube if you want. But where the people were inside the mirror, behind the mirror, they would be like virtual objects, okay? But that's just in the movies. So anyway, virtual objects, which we'll see a little bit later when we do combinations of lenses. A virtual object is an object that's behind the mirror or behind the mirror. So we'll tuck that aside for now, and we'll see it a little bit later. Now, the important thing for now is that if your focal length is in front of the mirror, it's positive. If the focal length is behind the mirror, it's negative. So, for concave mirrors, what do you think? Do you think they're going to have a positive or negative focal length? All right, this is the front. This is where you stand, and the focal length is right there. For convex mirrors, they look like this. This is the front, and the focal point is right there. All right, these are like shaving mirrors. These are like security mirrors. All right, so based on this little table then, I have a focal length that is positive for the concave and negative for the convex. The hard thing in this chapter is getting all these sign notations down. Now, what does a negative Q mean? What does a negative M mean? What does a negative F mean? Which mirrors have negative focal lengths? Which mirrors have positive focal lengths? But once you get that down, the chapter is pretty easy. Once you get down all the little notations about the signs, because the signs are really going to get you. So I try to put in these little tables to help you. So if the focal length is in front, that's for a concave mirror, it's positive. If it's in the back, that's for a convex mirror, it's going to be negative. All right, here's a couple of quick tests. Here, be careful here. My radius of curvature is 20 centimeters. That's C. But remember that the focal length is C divided by 2. And then you want to know what is the magnification. But then you also want to ask yourself, well, is this a positive or a negative focal length? It's a concave mirror, so go back and check. Is that a positive or a negative focal length? And then you can do your magnification, which is negative, oh, pardon me. Your magnification, which is negative Q over P. And you can use your mirror equation, 1 over F equals 1 over Q plus 1 over P to calculate the Q and the P. Notice that P is already given here. So you can calculate Q and then calculate M. But being very careful about, is my focal length positive or negative, and then actually finding the focal length. Okay, this one is difficult, so let me help you with it. Not difficult, but you got to think about this. So my magnification, remember we defined it in 2 different ways. Goodness, I'm sorry, I don't know what's wrong here today. But my magnification is defined in terms of the image height and the object height. So it is HI over HO. Now notice that my image is 5 centimeters. My object is 2 centimeters. All right? So I can figure out what is my magnification. My magnification is also equal to negative Q over P. Remember that the image is virtual, so you want to think about what is the sign of Q. And we're looking now for what is P. All right? So I'll leave you with that. You sort of have to think about the interplay between these two, and you can solve for P. I think there's one more here. Okay, yeah, again, this is a convex mirror. It gives the radius of curvature, and I want to know the magnification. This value is P. It's equal to 5 meters. You want to ask yourself, does a convex mirror have a positive or negative focal length? Is the focal point for a convex mirror in front of the mirror, or is it behind the mirror? And then once you answer that question, then you'll know if it's in front, it's positive. If it's behind, it's negative. And then you can use the mirror equation, 1 over F equals 1 over P plus 1 over Q to find Q. And then you can use your magnification, negative Q over P, in order to find the magnification. Okay. Next time we join, we'll pick up with ray diagrams and how to draw rays through these various mirrors.